Hello, and welcome to another FHIR for Developers tutorial video. My name is Gino Canessa. Today we're working on part 2 of the FHIR Search series. Continuing in, we're going to talk about some of the search parameter types, modifiers, prefixes, joining, things like that for multiple term searches, and see where it takes us. So let's jump right in. I'm starting here on the search page. We left off here before. You can see there's the summary table that had all of our data types. We pretty much ignored it last time, and we can start going through. Before we do that, I'm actually going to jump back to the patient. This is just the patient resource page. And as we said, search parameters are at the bottom. And we touched on this. You can see that here are each of those types. And so these types link back to the search page, the same links as these. And so just so that you know, that's normally how you would get there if you were looking for the details on how to do a particular search. You can see if you follow this link, it brings you to the same place as if you follow this link, so string. I will make a couple of notes on the organization of this page. I just clicked on the string link, but I'm scrolling up first. So there's this section here for search parameter types that is similar to the table that we had at the top for the summary table. And you can see that it has a little more description, some descriptive text for each of the types. And so that's pretty useful. Again, what we're trying to do here, the search parameter types are a little funny because what they're doing is bridging the gap between the URL encoded string, which is the parameters, and the data type that is in FHIR. So, we need to be able to do conversions for numbers, dates, strings, tokens, references. Some of these are for complex types. Even that it's not even just a straight conversion, but you have to look in fields within it. That's why you have composite things, things like that. So it's good to note that that's what we're doing, and that's why these data types don't match the FHIR types and don't match kind of what you would think of as language types necessarily, is because these are just to bridge that gap. After the descriptions on each of these, and again, these links go back down to the more detailed things below, but you can see there's these things called modifiers and prefixes. And so these are, again, to help control that bridging that happens between them. So string is one of the easiest to look at. And again, I'm going to be jumping back and forth a bit here, so I apologize. I'm actually going to grab this link first so that I can navigate back and forth a little bit. So you can see this is that link down to string, and it talks about a few modifiers. One is a contains, one is an exact, and one is the behavior with none. So by default, when we start, we're going to have if you just put in, a string value like given or just name in general, you have a begins with, so start of the field, and it is case insensitive. So this makes sense as a default search. If you start typing someone's name, someone's address, something like that, as you're typing, that's what autocomplete does and things like that, is it wants to fill out and it wants to be case insensitive so that if you don't capitalize the name, it's still, at the beginning of the name, it figures out if it's supposed to be a capital or not. It's a great default and makes a lot of sense. This modifier contains, that is just saying, well, I know that they had a Smith in their name. I don't know if it was their first name, well, first name, last name is based on this, but I don't know if it was, at the suffix of their name that they were something like John Smith or something like that. That doesn't make a lot of sense, but you see what I'm trying to say, that it might not be the beginning of the name, it might be the middle of the name, end of the name, different things like that. In this case, they're using Eve, so you can see the first one's matched Eve and Evelyn, but this also matches Severin. So you can see that it has the ability to look anywhere in the string. And then there's the exact. And the exact is just saying, this is exactly what I'm looking for. Now, the big note here is that this becomes case sensitive. So when you're saying exact, you mean exact. So you're not changing case, you're not adding accents, all of those things that these other ones ignore. So what does this look like in practice? I'm going to come back here to where we were testing. This is just our manual testing that we were doing in VS Code. And we have get-based search and post-based search. We'll do get just so we can see. And we will move our results so that we can do this. Perfect. All right, and let's get our screen set up a little for us. All right, so before we were playing with searching on the ID. Now we can just check the name. So, for instance, we can look for the name of test. Oops. There we go. And we can see we got back our bundle, and this is, again, doing a case-insensitive beginning of string search. So if we start looking here at the patients, we can see this starts with test. It happened to have a capital T, and actually the given name starts with test as well. So it matched those. Here we can see that this starts with test, and so it matched that. And you can keep going through and seeing that some of them have additional text, some of them don't. Some are capitalized, and if we keep scrolling, eventually we'll find some that are not. Here we go. So this has test with an underscore, but it's lowercase, and test with an O, but again, they're lowercase. So that looks, reasonable. And yeah, if we were doing autocomplete, having each of these types of things come up would make sense. And that's, I think, a lot of people are familiar with that style of string searching. Now, if we change to contains and we rerun this, we're going to get back more results. In this case, it doesn't even tell us how many more. But we're going to still find, like we had before, this first record that had test 2, test 1. So that's still a match because it still contains test. But now we also have here this name. So it's Jonas test. And again, you can see someone is just adding the word test here. But you can see it's not the beginning of the name, but it is the end of the name. So this is, if you've been using Visual Studio and things like that, kind of the autocomplete that you can skip words and, it'll still find what you're kind of looking for, or things like that. That's this kind of style. It'll look anywhere in the string for a match. And that makes sense, and it'll keep finding, again, case insensitive. So if you had a lowercase test there, it would still find it as well. And it still finds all the other results we had before. Now, when we change to exact, we get a different behavior. So when we switch to exact, now we can see that it did give us 306 results specifically. And you can see that some part of the name has to be exactly lowercase test. So here there was given and prefix actually. Same thing here. There's some duplication that happens when you're playing with test servers. But you can see that all of these patients have some portion of the name that is exactly lowercase test, and that's it. And I found 306 matches. And if we change this to a capital T, we can see that we have 450 responses. So you can see that is different, and now this one you can see matched. It's annoying because it has lowercase test there, but the given name is test, capital T, no other text. And that's going to be true on every single one of these. There has to be a segment of the name that is just test in this format. Perfect. So you can see that's how the modifiers work. We're saying kind of change the behavior of how we're doing this matching, how we're interpreting this value, and go from there. Perfect. So that's, you can see how string works. And if we go back to our types, we can see that there's these kinds of qualifiers for everything. So if we look at, for instance, a token search, when we're talking about tokens, we're talking about special strings. So URIs can be tokens, things like codes from code systems. You can see here there's a way of formatting code, system code, things like that. And there's some details about how you would map in specific to contact points, codings, etc. And then same thing, there's this list of modifiers you're allowed to use that work with tokens. So not, above, below, in. These all have special context, for instance, especially above, below, in and things like that. Those are code system tests that you're saying, jump into the tree of the code system and do matching based on those. So again, I'm going to kind of dive into specifics on some of these and kind of go over some of them just for time constraints. What's interesting is when we switch to things like dates. And so now we're going to switch from modifiers to prefixes. And this makes sense. These are on, and actually, I think here in prefixes, this has it. Yes. This has the types that use prefixes, and they're the number, date, and quantity, this set here. And really, these are just numeric types. So they're special things that you can put with numeric types to, same thing, control how we're using these parameters. By and large, they're just these mathematical things. This is the largest group of them. Equals, not equals, greater than, less than, greater than or equal to, less than or equal to. And you can see how that would work with numbers, dates, or quantities. That if you're saying, less than this date, greater than this date, lower than this quantity, greater than this quantity, equals this quantity, doesn't equal this quantity, those all kind of intuitively should hopefully make sense. This next set, we'll just use these two first. This is starts after and ends before. And so what we're saying is there's a range, and we want something that starts before this, or starts after this, or ends before this. So things like including 1 month of appointments, or people who had visits in this particular week, different things like that. So starts after, ends before, makes sense there. You can also see how those would work on some numbers and quantities and things like that. You're saying you have a sequence of values, but you want to know that the total values are less than a certain number, or things like that. More of a stretch. Really, it's with dates that I've seen those. The last one is approximately, AP. This is useful mostly, conversely, with numbers and quantities. So if you're looking for things that are about 2.5 of whatever, you don't necessarily want to have to search, the range 2.4 to 2.6. You can just ask the server for things that are approximately 2.5, and it's fine if it's 2.49 or 2.51. They're approximately 2.5. There is a bit of variation here, I'll note. You can see here the approximation is within 10% is the recommended way of doing this. And so some servers may do more, some servers may do less. It may depend on the type of resource you're looking at, or different things like that. That's going to be an implementation detail, because systems may choose values where appropriate. So, if what you're looking for is, approximately 2.5, and it's fine however the server is going to interpret that, that's great. If not, you can do things like specifically saying greater than, less than, and specify your own range. So both of those work. So how do they work in practice? Well, if we jump to date, because I think dates are always a good one to look at, we can see the first thing we need to know is the format. This is indicating it's the standard XML format for dates. That's based on the ISO format. It should be pretty familiar to most people. You can see it's just year, hyphen, month, hyphen, day, and then it has T separating time, and then if you're putting times, hours, minutes, seconds with colons, and then time zone information. So a pretty standard date format. And then this is what's used in all dates, date times instance. Again, we're bridging what we have as a generic date string into possibly a variety of actual FHIR data types. So you can see dates, times, instance, periods, timings, all these things you would use a date format like this in the parameter. And here you can see some of those examples we were talking about, and these kind of illustrate the equals, not equals, less than, greater than or equal to, less than or equal to, oops, one too many there, starts before, ends before, starts after, ends before, sorry about that, and approximately. And the approximate on date is a little a little awkward because it matches. And what is within 10% of a date, well, that's going to be up to a server. May check the day before the week, the day before the day after, the week before the week after. Again, that's going to be an implementation detail. So how do we use them? Well, same thing. Actually, let's make sure that we're doing these things all in order. If we go back to patient and we want to look for dates, one of the ones I like to use is birth date because, oops, wrong button there, sorry. We want to just check the date of birth. It's a pretty straightforward concept and is often filled out on these test servers. So, same thing, we can just do birth date and we'd have our date format. So we're just going to check January 1st of this year and see if anyone was born on that date. And what does it say? It says we have 18 patients that were born that day. Outstanding. And you can see they all have the matching birth date we want. Perfect. Well, that makes sense. If we put EQ, that's not going to really change anything because we just said same thing. We're looking, the equals is the default. We could say not equals, but that's going to return a very large list of patients, so we won't hammer on the test server like that. But again, what if we wanted, and we'll come back, bring our window back, we wanted to use a range, right? Because birth date is a single date, but we want to know people who were born in the month of January this year. Well, same thing. We can start putting things like greater than or equal to, so that's a good place to start. And so if we say greater than or equal to January 1st, we have a lot more results, enough that it didn't give us the number. And as we look at birth dates, and we'll see if we can quickly find birth dates, eventually we will get to people who were not born once we pass 18. There you go. So this is someone who was born on the 2nd. I said that thing about the 18 just because we knew there were 18 patients that were born on the 1st, and on this server the default paging is 20, so it's the last two. But you can see they were born on the 2nd, and if we look at the top of our results, we can see that there's this next link on how we could go and continue getting more results. So that's great, but now we need to actually specify the other boundary of our range. And the way we do that is actually just adding the parameter again. So I'll actually do this first. If we get rid of the range, the prefix there, we can add birth date twice. Let's say 0201. Now the problem is this is going to give us, it won't even try. When you add the same parameter twice, they're being ANDed together. So that's how you're doing things like if you wanted someone with a name and a birth date. It makes sense that way. So if you put birth date twice, it does the same rules. So here we're looking for people who have a birth date of January 1st and a birth date of February 1st of this year. In this case, the server knew that's not a valid search. No one can have two different birth dates in a single date field anyway. And so here it threw an operation outcome back at us. So I don't think we covered this in the first one, but instead of a results bundle, in this case we got this operation outcome resource, and it's a pretty straightforward resource. I think I have one open somewhere. I do. Oh, I do. Perfect. So with operation outcome, the description here is just sets of errors, warnings, or information messages. So it's just a way of a FHIR server saying in a FHIR model that there was an error and give us some details. In this case, you can see the error code and diagnostics, pretty straightforward. We cannot have multiple date range parameters for the same parameter without a qualifier. So the language on some of these things, qualifiers, prefixes, modifiers, I believe there's another one that's called something else that refers to them by a different name in the search parameter definition. There are going to be a few terms like that. the nature of having a large distributed group of people working on things, you'll see implementation details on some of these. So in this case, it said that's not a valid query. So we do want to always be checking that we got an operation outcome or a bundle so that we know what we got back. So how do we actually specify the range? Well, we said we knew we wanted greater than or equal to the 1st, and then we could say less than February 1st. When we do that, it knows that now we had a valid date range and gave us the 126 results that are people born within that range. So, perfect. We can specify date ranges, you can specify quantity ranges, any numeric kind of value. Give me people that have, blood pressures in these particular ranges for these values, things like that. That makes sense. We use the qualifiers as this particular server called them, but they're called prefixes in the standard here. So that does bring up the question, if we jump backwards to name, I just wanted to introduce this concept first, how do we do multiple names? So, for instance, if we said we wanted name exact equals test, we again get back our 306 results, but we also want the people who have, test as their uppercase name, or test in all caps. So 450, 306, 142. You can see there's a few variations that they all have different results. Now, obviously, the first thing we can do is say, well, we'll just run the query multiple times. Generally speaking, we're writing software. We can do multiple queries, or we can even put all the queries together in a batch, and that works. But it's not really what we want. Now, as we said, if we go through and try and do this, it's actually going to give us an interesting behavior, just because we're doing fields that have arrays instead of before that where we had the date things. So you can see there's 6 results that actually match this. And what this is saying is, give me someone who has exactly test with lowercase and exactly test with a leading capital. And so you can see these have test with an uppercase and test with a lowercase. That's a great query if that's what we were looking for, anyone who is named test, but probably not what we were interested in, because what we want is anyone who has either of these. Now, jumping back to the specification, this is actually kind of a little bit hidden to find. And let me make sure I do it in the correct one. I believe it's in composite. Yes. So this is where the syntax is outlined. And again, we do have tickets open to revise some of this documentation. But we can see that there's this comma syntax that it uses. And so this is talking about exactly what we want. And parameters versus or parameters. When we just put the parameter multiple times, we're doing ands. And again, that made sense. When we did the date range, we wanted things that were greater than or equal to this date and less than this date. Perfect. And makes sense. An or there wouldn't be useful. You can see it makes sense when we're doing multiple fields. If we say we want someone who his name has a Smith in their name and was born in January. Perfect. Those things all make sense to have the ands. So to do the ors, you use this comma syntax. I'll note that it's defined on string types and things like that. And again, that's not super clear here. We are working on it. So following that through, we can just do this. So now, instead of our 6 results that had both, we have some number of results, and we can get into how you would ask the server to tell us regardless. But now we have people who have either just the capital test, just a lowercase test, or some combination thereof. And so there we go. There's ones. Actually, this one has both because oh no, we did exact. So we have the lowercase test and the uppercase test. And the only time you have to worry about casing is when you do the exact, because every other string search is case insensitive. But if you knew that you had the patient's last name, like in my case, it's Canessa, and I did this search because I'm looking for it and I didn't find it, I can say, well, Maybe they typed it as Canessa, maybe they typed it as Canessa, things like this. In this case, it didn't help because none of them are there. But again, if we did even just this plain search, this doesn't make any sense because these are all the same value. So it can really ignore all of this. Oops, it can really ignore all of that and just do this. That's the same search because it's case insensitive. Perfect. So we can see how we can join things. We can do the ands, we can do the ors, getting into some of the different data types. These chaining and things we'll get to in a little bit. They're even more complicated. But you can see each of these data types, and again, these are just here on the search page, talking about, oops, I think I can just do this. There you go, data types, P types, numbers, strings, dates, how to bridge from whatever you can type in a string into whatever that FHIR type is. You know, composite is an interesting one, just as we talked about. This is where we had the and or discussion, just because this is where it happened to have been added at the time. But it's talking about here, you know, going inside this characteristic value from group and saying, well, I want things where the gender is mixed or the owner is Eve. Things like that you can do these composite searches. In order to find one, you have to go, for instance, to group. You can see that the data type is composite. And so you can see here, it makes sense. It's a specially defined thing saying within a group, we have a characteristic, and we want to be able to search a particular code and value combination. So that you can say, I want things that only have this and this in one query parameter. It's called composite because you could just do a search that has this characteristic and this value. You can see they're both token searches. And so it's just kind of a shorthand way of putting those two together. And so that's why it's a composite. There we go. Perfect. So that's those tokens we talked about, strings, numbers, and again, same thing, numbers. You can see there are examples using the different prefixes, doing less thans, greater thans, not equals, all those kinds of things. References, same thing. It's essentially just a special string type, and you can have the ID, or you can have the type / the ID, or you can have the URL. Any of those are valid patterns to use when you're doing a reference. You know, again, doing things like contains and things like that aren't officially here on reference. So when we have modifier, we say you can just do a type, and then you can do identifier for some parameters above and below. These are not highlighted correctly, so don't know if there's a ticket for that one. So I'll make a note of that. But you can see that those are the ones that are defined. You can, you know, theoretically think of ways of doing searching for, you know, contains within an ID or different things like that. It's not defined. If a server wants to support it, it can. But it's you know, a lot of servers just say a string is a string and I don't care. And so there, things like that, if you really need that kind of behavior, you just need to test with the server or go and define a custom operation and things like that. And then same thing like URI, you can see above and below. And so you can do things like, well, I want things below hl7.org/FHIR, and that's assuming anything after that is valid, or just hl7.org, and so then FHIR would work because that is below hl7.org. Kind of an odd way to think about URIs, but it does make sense. Same thing if we look at special. I just want to talk about that, and that is essentially the catch-all. And so anything that's defined as special, we'll talk about how it works, what it's actually doing. So you can see like filter is defined as special, and it has this whole page describing what it actually means to have this. Because it's not a standard type, it's not mapping to things, it's not common enough that we're going to go and codify this as a general rule that everything needs to support and etc. It's just saying, oh, if you're using filter, then this is how it works. So it's pretty uncommon to see. Near is another one that is saying, well, what does near a location actually mean? Well, depends. So in this case, there's no cut and dry definition mapping that goes between them. So that covers kind of a run through of all the data types and prefixes and modifiers. And again, there's no great link to this, so I'll make sure to put it in the GitHub repo as well directly, just to make sure that you can get directly to this section as well. But I think that's probably a good stopping point for this video. So we'll pick up next time with some of the more involved things that you can add that look like modifiers, things like iterate and chaining and some of those kinds of things, perhaps. Actually, we have quite a bit of search yet to cover. So thanks for watching. If it helps, please, or you have any questions, comments, please let me know. And if not, we'll see you next time. Cheers.